Hello, hi, good morning, good afternoon, good evening. This is Tasien. I'm happy to be here again. Welcome back to Mathify Analytics. In today's video, I'm going to show you how you can calculate probabilities in Python. And I'm using the Jupyter Notebook in Visual Studio Code. Yes, so to calculate probabilities in Python, we need at least these two main libraries, the scipy library and the matplotlib library. So make sure to install them if they are not installed. So for me, I don't need to install because they are already installed. So if you have not yet installed, make sure that they are installed. And then from the scipy.stats, we have to import the binomial and the Poisson, because in this video I'm going to show you at least how we can calculate the binomial probabilities and the Poisson probabilities. Then like that you can adapt the this tutorial to other probability distributions. And we also need the matplotlib for plotting the probabilities that we are going to calculate. So then, for instance, let's start with the binomial probability. Let's suppose that we are going to flip a fair coin 10 times, and the outcome of interest for this moment is the number of heads that we can get when we flip 10 times a fair coin. So the number of heads that are the possible outcomes then be 0 heads in those 10 flips, or 1 head, or 2 heads, or 3 heads, or 4 heads, or 5 heads, or 6, or 7, or 8, or 9, or 10. So we are interested in how we can calculate the probability of having, let's say, 0 heads out of these 10 flips, or the probability of having 5 heads out of these 10 flips. Yeah, so then or what you can do first, we have to set up the parameters of our binomial distribution. Let's say we have to setting parameters. Parameters. So the parameters for our probability distribution is n, and for in this case n should be equal to 10 because we are flipping the coin 10 times, and the probability of having a head when we flip a coin, it is equal to the probability of having a tail. So the probability of success in this case p is equal to 0.2. Yes. So now, since we are all set with the parameters, we can also define, let's define what? Define the sample space. We can define the sample space. In this case, the sample space is the number, let's defining of all possible outcomes. In this case, the outcomes are heads, so it's like we have to define this set x, which is equal to either 0 and 1, and so 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So then how do we do this? Let's say let me call it k values, or k values. So this will be a list. This is a list of these numbers. Then it will be range n plus 1. This is 11 possible values. Yes. So if you want to see this k var, you can just write k var. This is k var. Then like this, these are our values. This is the possible outcomes that we can have, but we are not interested in this. We are only interested in calculating these probabilities. So how do we calculate the probabilities of these possible outcomes? For instance, if we want to calculate the probability of having no heads, so then we need to call this binom function. Then it's binom. Then we compute the probability mass function. Then this is the PMF. And then what do we need? We need the outcome value. The outcome value is 0, and the number of flips, this is the n, and the probability of success. And the probability of success is P. So if we compute this one, we will get the probability to be this value, 0.0009. If we want to compute the probability of having, let's say, 7 heads, then we replace 0 by 7, and if we compute it, we get this probability, 0.11718, and so on. So if we want to calculate all the probability for all these possible outcomes, then we can type kvar here, kvar, which is the vector of all these possible values, and then we compute them, and then we get these values. So this means that for to have the probability of having 0 heads is 0.0999, probability of having 1 head is 0.0997, and so on, and the probability of having 10 heads will be 0.00097, and so on. But let's store this one in a vector, so that we will be able to use them to plot them. Then if I store them in a vector, let me call this vector, let's say, binomial PMF, then equal this one. I have a vector of these probabilities, and if you want, you can also print them in a smart way. Let's say print in a way more smarter way. Then we can have this k value, or let me say k, and separated with tab, and then probability of having x equal to k, probability of x equal to k, and then we can print all these probabilities. How? Let's say for value var in range, or yes, in range n plus 1. Yes, what do we in range n plus 1, not n plus 10, n plus 1, we need to print those probabilities. We print, what do we print? We need to print no, we need to print this. I need one column of the outcomes, and the other column will be the corresponding probabilities. So we need the k var, we need the k var. Yes, and what do we need? I need to separate this with tab, and then followed by these probabilities, and the probabilities are stored in BPMF, then BPMF of var. Yes, of var. All right. Yes. Then if I print this one, then they are printed in a better way, like this. You get this list, this table. So then we have the outcomes and the corresponding probabilities. So to get 0 head, we have this probability. To get 1 head, we have this probability, and 2 heads, this probability, and so on. 10 heads, this one. But these probabilities has too many decimals. You can also reduce the number of decimals if you want to reduce the number of decimals. Let's say we need 4 decimals. You can add here these. What do we add here? Then for F, we have the 4 decimals like this. Then you have a very nice table which shows you the possible outcomes and their corresponding probabilities. So you see, this is nice. Like this. Yeah. So, and if you want now, we can plot these probabilities. And to plot these probabilities, we will use this matplotlib and then this PRT. How do we uh, plot these probabilities? We use this PRT. This is prt.bar because we need bar plots, and in this bar function we need the outcomes, and our outcomes are stored in kvar, and we also need probabilities. So we need also probabilities, and the probabilities we have stored them in bpmf. And if you need, you can also add the color. If you need, you can add the colors, but this is not necessary. So if we leave it, then it will take the default color. But you can change the color if you want. And if you want, you can add the title. Then to add the titles, you use this plt.title, plt.title, title, yes, and you can give a title as you want. Is this the probability of probability binomial probabilities, binomial, let's say binomial probabilities having n equal to number of trips equal to 10, and the probability of success equal to 0.5. This will be the title. You can give any title depending on what you are calculating, and you can also give the x labels and y labels. So for the x labels, you just type plt and dot x lab, x labels lab, and then this is the number of number this is the number of success. Of course, you have to use a string. This is number of success, number of success. This, in this case, this is the number of hits. Yes. And then we can also add the y labels. For this case, the y labels, you use plt y labels, and the y labels, this will be probabilities. And then what else do you do? What you do is just, let me maybe increase the character so that you can see what I'm typing very well. Some people claim that they are small characters, but now it's good. And then after this, you type plt, and then you show your plot. Show, not show, but show. Yes, and like this. And then we can produce our graph. And the graph is down here. You can see the graph. Let me make it a bit smaller so that you can see it well. Yes. So you see the graph. So now we have our binomial probabilities already calculated. It's the number of heads. See, yes, and then the number of probabilities. So what else can we do? We can also now calculate the mean and the variance of our binomial probability distribution. How do we do this? To calculate the mean and the variance, we use the binom.stats and the function binom.stats. And let me write it down here. We need the mean and the variance, and this will be equal to, we use this binom.stats, and then it has to take the number of flips, the n, and then the probability of success p. So if we do this and we compute this, we will get them down here. Where is it? Where is it? Okay, I have not printed them. Let me print them. Okay, so let's print them. Let me make this one bigger, a bit bigger, so that you can see it very well. All right. Right, let's print our mean. We print the mean. Let me say print f, and then mean equal mean equal. Then what do we have to compute? We have mean here. Yes, all right. I don't need that one. Yes, mean. And we also want to print the variance. Then print f. And what do we want to print? Sorry. What do we, where am I typing now? Shit. Yes. Okay, we need to print variance. Variance, and what variance equal, and then this variance will be equal to this variance that you have already computed. This is var. Yes, and then if I run this, what do I get? I will get the values down here. Where are they? They should be down somewhere here. Yes, then I will get the mean to be equal to 5 and the variance to be equal to 2.5. So you see, then like this, we have our probabilities computed here, and we have also made a graph of these probabilities, and we calculate the mean and the variance. So isn't it easy? Yes. So then for the Poisson distribution, how are we going to do? It's just changing the binomial function that we have been using. Then we can use this Poisson function that we have already also imported. Yeah, so I think you remember what it means, a Poisson distribution. If you don't remember, please you can watch our previous videos where we discussed about the discrete probability distributions. So in this case, let's take one example of a Poisson distribution. Suppose that in average I receive 4 emails per hour. Okay, in average, suppose that in average I receive, I receive 4 emails, 4 emails, 4 emails per hour. Every hour, per hour, I receive 4 emails, and the one can ask, what is the probability? What is the probability? The probability of receiving of receiving of receiving 5 emails, 5 emails uh in the next hour, or yes, in the next coming hour. In the next coming hour, in the next coming hour. So uh, we also have to set up parameters for our Poisson distribution, and as we know, the parameter that we need is this average number, and I used to call it lambda. Let's say lambda var. Let me call it lambda var, and lambda var equal in this case 4. So then if I am to compute the probability of receiving 5 emails, instead of using binomial, because this is a Poisson distribution, and we use function Poisson. Poisson, yes, Poisson dot probability mass function. Then what do I have to enter here as arguments? It takes this 5 number of the outcome that I need to compute the probability, and also the average. So the average in this case, this is our lambda. This is our lambda var. Yes, 4. Yes, like this. And then if I compute this one, I will receive this one. The probability is this one. Yeah. So that's it. But how about plotting? But to plot, you need many values. So let's say, let's suppose that I have a range of different values, outcomes. Let's say that I have these outcome. Let me call them R var. Out these outcomes. Let me say that I have a range of outcomes from let's say 0 emails to 15 emails. Let's say here 16. Yes, but it should be a list. Okay, let me list them like this. Yes. Let me say that I have these different outcomes and I have to compute the probability of having these outcomes. Then the probability, let me call it Poisson PMF. As we have done for the binomial, then in this case we use Poisson and Poisson dot PM dot PMF, and then instead of just entering one value, I have to add or this list of values, then R var, yes, R var, and then also the lambda value, lambda value. So then I will get the probabilities here. And if you want to list them as you have done before, you can do so, but I don't think that is interesting now because we already know how to make this kind of list, easy lists. If you want me to repeat it, I can repeat, but I think it's not necessary. We know how to print them. And then if we want to display them, I can write this PMF. Yeah, then if I display them, they are here. But if you want to display them nicely, make a table as we have done before. So let's plot these. Let's plot these probabilities. If you want to plot them as before, use plt dot bar, and then in here we need the values, outcomes. These are var. We need this var, and we also need the probabilities. The probabilities here, this is the PPMF. Yes, the probabilities. And if you want, you can add the color of your bars, but this is not necessary. And then you can add the titles as before. This is plt dot title dot, yeah, title. Yes, title. All right, the title. Did I write title in the correct way? Is it title like this or the two? Title, title. Is it title with the how do you write the title? This is funny. This is title with T one, one T. I'm getting confused. Then T. So title, then you add the title as you want it. In this case, this is probability. Poisson. This is Poisson probabilities. Poisson probabilities with lambda equal to lambda, or the mean average equal to, let me write average value equal to 4. Yes, yes, and then you can add the x labels, and as before, this is plt dot x labels, and then you add your labels. This is the possible outcomes, or yes, this is possible outcomes, or yes, possible whatever you want to call it, possible outcomes, and or you can just write the outcomes. Yes, outcomes, and then you can set up the y labs, and then these are probability, and then you can show your plot. This is plt dot show as before. Then you show your plot, and if I compute this one like this, I have my plot down here. I make it a little bit small so that you can see it. All right, yes, I have my plot here. This is the Poisson distribution with average equal to 4. And again, if you want to compute the mean and the variance, as we have done before, you will use Poisson.stats and you use the lambda value in your computation. Let me calculate it too. Uh, I write it somewhere here. Let me take another tab. Then, if you want to calculate the mean and the variance, this is mean and variance. And variance, this is done is given by Poisson. Poisson dot stats, and then you have to enter your lambda var, then your lambda like this. Yes, if I compute this, and then if we print this, let me print it, the mean, the mean, f f then the mean will be equal to this mean. This is the mean that I have already computed, and the variance, sorry, what am I doing, and the variance, and then we print the variance, and the variance will be equal to this variance that I have already computed, var. Yeah, so if we run this code, we will get our variance and the mean here, down here. So the mean is 4 and the variance is also 4. Okay, yeah, all right. Yes, anyway, so that's how we can compute uh, the probabilities in Python. Compute the probabilities and the graph, they make a graph of those probabilities. You can adapt this method to any probability distribution. So if it's binomial, or if it's Poisson, or if it's normal, then make sure to import the correct distribution. Here we have used the binomial and the Poisson because we need the binomial distribution and the Poisson distribution. But if you want, for instance, the uniform distribution, you make sure to import the uniform. If you need the normal distribution, make sure to import the norm. Yes. All right. Thank you for watching. I hope you have gained something, and it's also comprehensible and you can understand everything that I have done. But yeah, so if you have any question, write the question in the comment section, or I can give you like a one challenge. Can you like go ahead and calculate the probability of getting, let's say, uh, 20 emails, 20 emails in an hour, and write your answer in the comment section. Yes, use the techniques that I have shown you here in this video, and calculate the probability of getting 20 emails. If you know that on average I get 4 emails, and write your answer in the comment section. Thank you for watching, but yet, if you have not yet subscribed and you wish to see more videos like this in the future, make sure to subscribe to our channel and turn on notification bell so that you get notified anytime we upload a new video. Ciao, thank you for watching.